Hello, let's continue our Sudoku adventure with That's an Odd Renban by Toir. This is actually a debut from Toir, so welcome Toir. And all right, so let's go over the rules. So we have normal 6x6 Sudoku rules. That means in every row, every column, and every 2x3 box, we are placing the digits 1 to 6, exactly once each. We also have these sort of brownish yellow lines in the grid. Those are called Nabner lines, which is renban backwards. So they're kind of anti-renbans-ish. So what does that mean? That means that, first of all, digits can't repeat still on these, just like renbans. That's not important for this puzzle. But what happens is if I put a digit on a Nabner, say I put a 2 on a Nabner, then none of the consecutive digits, 1 and 3, can be on the Nabner at all. So I can't put a 1 or 3 here, and I can't put a 1 or 3 here, now that there's a 2 on there. And so then if I did put a 4 on here, then now I can't put a 1, a 3, or a 5 here. So that is Nabners. We also have quadruples in the grid. So that's these circles with the numbers in them. So this 3 and 6 tells us that in these 4 cells that touch the quadruple clue, we must contain at least one 3 and at least one 6. So the digits in here have to appear at least once around it. The 2, 4 is the same. A 2 and a 4 have to appear at least once around here, and the 1 and 5 here. Finally, we have these even and odd cells. So the squares are even and the circles are odd. The way I remember that is squares have an even number of sides and circles look like O's, which is the start of odd. All right, so those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started now. All right. So I'm going to start by just penciling these even cells 2, 4, 6 and these odd cells 1, 3, 5. So, okay, it interests me that we have this 2, 4 in the quadruple, and then we also have these 2 4s, because that's 6 evens. So if you think about, if you think about 2 rows, how many evens are in 2 rows of a 6x6 Sudoku? And the answer is there are 6, because there are 3 in each row. There's the 2, 4, and 6 appear in each row. That's 3 evens per row, so there are exactly 6 evens in these 2 rows. Now, how many have we accounted for? Well, we've accounted for 4 of them in these squares, and then we've accounted for 2 of them in this quad. So that means a few things. First of all, it means we can't place any more evens except in these cells. So these cells here have to be odd, which are suspiciously on these 2 Nabners. But it also means that the 6 has to appear here. And I think the way I'm thinking about that is we can't put a 6 in here, because if we did, we'd still need the 2 and the 4, and now we'd have 7 evens. So I think there might be a cleaner way to think about that. But anyway, there's a 6 in here. Now one of the 2 4s is here, and one of the 2 4s is here. So the 2 4s are either like this or they're like this, because we only get one more even here and one more even here. So that's another way to think about it, is we're going to end up with like a 2 4 like this maybe, and that's going to make a 2 4 6 triple, which puts the 6 here, and a 2 4 6 triple, which puts the 6 here. Or we'll have it the opposite, which still makes the triple, right? We can't do this because that's too many evens in the row. We can't do this because that's too many evens in the box. So I don't know that we know which way it goes. Do we? I don't see how we would. Okay, so I think we should think about these Nabners. Maybe we'll start with this one, just because it's at the top. I don't know. I don't know which one to start with. But anyway, okay, so the 3 and the 6 aren't in these cells. So I think I do want to pencil this Nabner with 1, 2, 4, 5, which are just the non-3, 6 numbers. So the 1, 2, and the 4, 5, we're going to have 1 of 1, 2 and 1 of 4, 5, because if we can't do a 1, 2 and we can't do a 4, 5 in here. Oh, I see what's going on. Okay. So if this was a 1, for example, if this was a 1, then that removes 1 and 2 from these cells, because you can't have a repeated 1, and you can't have the consecutive digits with 1, which is 2. And so then this would be 4, 5, which breaks the Nabner, because they'd be consecutive. So we can't have a 1 here. And 5 does the same thing. If this was a 5, then that would remove 4, 5 from here, and then this would be a 1, 2 pair. So this is a 3. That removes 3 from these. And with the 3 here, that means this is not 2 or 4, so that's a 1, 5 pair. So these are 2, 4, 6. Okay. So let's think about this one now. We can do the same thing. This is from 2, 3, 4, 6. So this 1, 5 is a little bit different. Is 1 problematic? 1 is not problematic. 3 removes 2, 3, and 4. That is problematic. If this was a 3, then 2, 3, and 4 would be gone. We'd only have 6 left. So 3 is problematic. And then 5. Oh yeah, so 5 removes 4 and 6. And that's still a problem because we'd have 2 and 3 left, and those would be consecutive. So this is a 1 then. That's pretty neat. I like that logic a lot. Very clever. So the 1, the 2 is removed. And I guess we could say there has to be a 6 here, because if there wasn't a 6 here, then it would be a 3, 4 pair. So this is not 6. That places this 6 and this 6. Okay. So this row needs 1, 2, and 4. Ah, so that's the 2, 4. So we have a 2, 4 pair here. So that's a 1. Now we knew that these would be in corners. This is the other 2, 4. And then this is the 3. Okay. And we know these are a pair, but I don't know that that does anything right now. All right. We're 5 minutes in, but I have been explaining a lot, so I think it's not too bad. So I think we need to look at this Nabner here. And we have the 1, 3 here. So I'm wondering if there's 2 properties of Nabners that... Oh, okay. I'm going to explain both properties, but I think one of them is going to be the most important. So a 3-cell Nabner specifically, and a 6x6 specifically. If you think about it, once you put a 1 on it, you're not putting a 2 on it, right? And then once you put a 3 on it, you're not putting a 4 on it. Once you put a 5 on it, you're not putting 6 on it. So it's kind of like we're going to have 1 of 1, 2, 1 of 3, 4, and 1 of 5, 6. And kind of the way to think about that is if I omit both 1 and 2, for example, then what am I going to fill in this cell? I can't put a 3 or 4 in it, because no matter which one this is, it can't be 3 or 4. And I can't put a 5 or 6 in it, because no matter what this is, we can't put a 5 or 6. And so we're stuck with no digits if we don't want to put a 1 or 2 on it. So we need 1 of 1, 2. And it's the same thing's going to happen. You can do it yourself with 3, 4, and with 5, 6. So we're going to have 1 of each. That's one property that I think is interesting. The other property is with 2s and 5s. If I put a 2 on a Nabner, then 1 and 3 are gone. But remember, we needed 1 of 3, 4s. We have to put a 4. Now remember, we need 1 of 5, 6. We have to put the 6. So the 2 actually forces them to be completely even. So once you have a 2 on a Nabner, it's completely even. And then the same thing happens with 5, actually. If you have a 5 on a Nabner, then it has to be completely odd, because that removes the 4, so you have to put 3, which removes the 2, so you have to put 1. Now look what happens with the 5, though. If I put a 5 on this Nabner, it breaks both of these cells, because we can't put 3 odds here. We only get up to 2 odds. So I can't put a 5 on this Nabner. So with no 5 on the Nabner, there's a 5 on one of these two, which actually looks right, making this a 1 and a 5, and now this is a 3, which means there must be a 4 on the Nabner, which means, and we know there's no 5s, there must be a 6 on the Nabner, and then there's a 1 or a 2 on it. So this is from 1, 2, 4, 6. That's not 1, that's not 6. Can we narrow it down further? Oh, right, there's no 2 on it because there's a 3. Sorry, that's not true. I was going to say because there's a 3 here, there's no 2 on it. That's complete nonsense. These are from 1, 2, 4, actually. Now, what can I do with that? Oh, the 6s look up. This is not a 6. So this has to be the 6 for the Nabner. We need one of these to be 1 or 2 and 1 to be 4. So there's a 4 down here. There's also a 6 down here. And the 6 is placed. So that's a 4, that's a 6. Because the 6 looked at this cell. So this is a pair then, and that should help. This is a 2, 3 pair, so that means there's no 2 on here. So we get the 4 and the 1. That's a 2. These don't have a 4 on them. So this is the 5 for the column. This is a 4. All right, this is 5 for the box. Nope, not 5 for the box. This is 2 for the box. This is a 1-5 pair. All right, good progress. Now, we have the same issue here. We can't put a 5 on here. So the 5 for this row is going to go here. That makes this a 3 also, which means there has to be a 1 on here. That's there, because the 3 removes the 2. There has to be a 6 on here, which goes there, because the 5 is gone, and then there's a 4 on here. So I think the 3 always forces this to be 1, 4, 6, which is pretty interesting. And the reason for that is the 3 removes the 2. So you have to put the 1, and then the 5 is broken because now you've put the 4 on there. So yeah, that's interesting. And then let's just finish the puzzle with the 5 there. Sorry, I should have finished first before analyzing. But yeah, that's actually a really interesting property, that if a 3 sees an Abner, it must be 1, 4, 6. So that's something to add to the toolbox there. A 3-cell Nabner in a 6x6 that sees a 3 must be 1, 4, 6. Yes, good knowledge to know. Very cool, building that puzzle around that. I liked the idea of starting with all the evens known here, which forced these to be odd. And actually there was only one odd that worked because of what you removed from these cells. And then finally teaching us that 3s in these cells force the 1, 4, 6 pattern. Interesting. Cool. Well, I enjoyed this. I hope you did too. And if you did, then why not leave a like, subscribe, and a kind comment below.